Okay, this is building query for August 10, 2020. And we had kind of tweeted out a mini agenda, which I actually got wrong because I remember we wanted to talk about remotes, particularly with respect to the work Vulkan was doing when he was kicking around with query, as well as let Kasey demo some of the test, what was it called again? Test production, test something?
Test ground.
Test ground. So I think we've got Vulkan for a short period of time. So let's make sure that we address their issues, stories, concerns, or whatever, or just make sure we spend some time talking about the things that they were interested in us. I think we met, to Chris's point from earlier today, we met Vulkan over lunch a couple months ago, many months ago, a different lifetime ago. Chris or Vulkan, do you want to kind of summarize the content of the email exchange that led to us potentially reaching out and talking a little bit about pushing data sets to remotes? And what that is.
Vulkan, do you mind if I take a stab at it?
Yeah, go for it.
Yeah, so I think Vulkan described a scenario where he's built custom UI for sort of distributed set of customers to be able to log in and input data, including spatial data, for things that exist out in the world, and they just kind of need to constantly be updating that and making sure that they're creating new assets and updating existing assets. And I think there's a desire, if I'm not mistaken, to have that be more of a craft the changes locally and then push when they're ready. And then that can, if you have version control in place, you can know who made changes when and when the data set was updated and what changed, and then be able to ingress that into your production database that actually ends up in your app. Does that sound reasonable?
Yeah, I mean, it covers part of our use case, and I'll get into the other part right now.
Perfect. Thank you so much, Vulkan, for your time. Do you have any last questions?
No, I mean, I think you guys have done an amazing job so far. I am really impressed by how it's shaping up. I'm really looking forward to where you guys are going to take this.
Awesome, and thank you for joining an open source call. Yeah, Rico, I think you're about to say the same thing.
Yeah, just really appreciate you taking the time out of your day to join us. We appreciated hearing from you and learning a little bit more about what you're up to.
Yeah, no worries. So I have to jump off. Thanks so much, guys.
Thanks so much, Vulkan.
Take it easy.
Bye-bye.
Bye.
Lovely. So,
Cool.
that was delightful. Nice to meet Vulkan. The other thing we had on the agenda was a demo of testground and the future of P2P and how we're going to make this go together and work together. Kasey/Ryan-Fox, do you have? Are you prepared to demonstrate?
Hello. Yes. Hi. Cool. So where to start? So we are experimenting with using testgrounds, which is a libp2p project that makes it easier for you to test networks, peer-to-peer networks. So I can show you guys a little bit about, I could show you an example test plan we have right now, and how it's been used to help us improve our P2P story. Basically, we've been having issues with one specific thing, upgrading to a query connection, we call it, which means for us, hey, we know that you're a query, we know that you're part of the query network, as opposed to someone who is an IPFS node. Like, we still receive many IPFS connections, and it's important for us to be able to distinguish which one of those also speak query. And so we've been having problems around our story about establishing that connection and making sure those connections are valued and exchanging information about each peer once you realize that connection has happened. So in a recent refactor, we've removed a bunch of where we are currently is different from where we're going to plan on going, but where we are currently is a simple ID service that is based loosely on the way that IPFS libp2p does an ID service. Basically, hey, who are you? What's information that I need in order to be talking to you, connecting with you? Ours is a much pared down version of that. When we see that an IPFS connection has successfully happened, we then do what we call profile exchange. So we basically, on our side, all we care about is their information. On their side, we're going to expect them to ask us for our information as well. So we just send out a simple request that says, hey, what's your profile? And we wait for a response. And we're coordinating that to make sure that, hey, if we somehow find this peer multiple times or very quickly, we're only asking for that profile one time. We're not slamming the peer with a bunch of different requests that all are the same thing. And the way we've been testing this is using test grounds. So I can actually show you that in action. Let me share my screen. Where are you? Terminal. Share. Okay. So test grounds, which is the tool that the libp2p team, IPFS team maintains. Basically, it's a separate tool. You have to download it. And right now, building from source is the recommended way. And in order to get started, you have to run the test ground daemon. Test ground daemon. Why can't I type? So basically, the test ground daemon is its own little server that's coordinating multiple networks that are getting spun up when you run your test plan. They call it test plans, are the things that are the actual test cases that you are running. So when you run a test plan, you have the network that is the actual, like the nodes that you have created, the instances that you have created that you are asking to connect to each other, exchange information, blah, blah, blah. That's one network. There's also a network that test ground controls, which is basically like a sync network. It's the thing that you coordinate everything on because there's a lot of coordination that needs to happen when you're creating these nodes. And I'm actually going to show you kind of a fun thing that you guys will see with this coordination. So this is my test. To run a single test, you do test ground run single. The plan is called query. The test is profile exchange test. I'm running it locally. You can also run it through Docker, but this is just so much more faster. So that's better for this call. We're building it. It's a Go program, and we are executing it locally. And I'm actually going to use 4 instances. So I'm spinning up 4 query instances. And the goal here is for them to connect and exchange profiles. So let's just run this and see how we do. So yeah, first, you're going to see a bunch of, this is also like relatively difficult to parse the output that comes out because there's just so much of it. And there are some test ground tools that help you parse that, but I'm just going to show you guys what comes out of our plan in the terminal here. You'll see at first a bunch of nodes building. Okay. So, oh my gosh, so much activity. Let's start at the top here. First, all the test grounds, like registering its like ports that it's going to reserve for its own, for like that particular instance. So each of these, they're nicely color coded for us, is a particular instance that's getting spun up. We see here, and I made this, this is a little bit formatted weird so that it stands out. The first thing that'll happen is that the test plan will create and set up a network and or set up and connect to its own network. The thing when it's local, all of this is just happening as quickly as possible. if you're using something like Docker or pushing to like Kubernetes cluster that's running these instances, you can actually do things like adjust latency, packet loss, so that you can simulate actual like network conditions. But here, everything's just going full speed because you can't do that when you're executing locally. So we connect to the network, or we set up the network. That's where you can also like get a particular IP address for your own node. And then we set up and create what we're calling a query. We call them actors. So each node will, each instance will spin up a node. And so, for example, here's one with its own query ID, its own IPFS or libp2p peer ID, and some addresses. Now, this is just for human consumption so that while you're looking through it, you understand that something is happening. And you'll notice that we actually start exchanging profile information or requesting profile information before every actor has been set up. Hold on. It seems like we might be, yeah. Okay, so part of the reason that that's happening is because we're running locally, the speed at which a node spins up and then the next node spins up, and how quickly that they enter the network and start exchanging like IPFS messages and libp2p messages happens very, very quickly, and when everything's on one machine. So we're actually finding these query connections before we actually explicitly dial. So later on in the test, we do an explicit dial in case, for example, like the last node is going to need to explicitly dial all the other ones if it hasn't entered the network at a time when the others are exchanging information with them. So we explicitly dial, and that also triggers a profile request. Now, I think I might be frozen here. So I'm just gonna start this over. Let me see. There's also output that happens. Here we go. Yeah, interesting. Let's just try that again. But yeah, so these profile exchange, you'll notice that these profile exchange requests are being sent, and we're getting events. So we're hooked into a bunch of different events. When we request a profile, when we receive a profile, when it fails, when it happens successfully, we're hooked into all these events, and we use those hooks in order to communicate to us, the human, that anything's happening on this network. And then when it successfully happens, I will be able to show you the actual output at the end here. I also might have. Made some weird. Yeah, okay, so do you see how it's stopping on this waiting for all connections to send profiles? I was futzing with this just a moment ago, and part of the thing that's like a big gotcha on when using test grounds is because you're having to coordinate the entire network, you have to do a lot of syncing between the different nodes. So you don't want to dial all the peers until you know that all of the peers have been created. You don't want to close the peer before you know that every peer has attempted to dial each other. So you end up coordinating a lot on, you end up having to coordinate these things, but then if you put the sync in a weird spot and you don't have all of the things happen at the right time, then you can get things hanging like it's hanging right now. And that's because I was futzing with this right before the call. So let me actually see if I can, because I have been doing this.
I think that's a great demo case. This is really nice.
Yeah. Okay, well, hold on. So on a successful thing, after all the connections have been sent, each one lists all the profiles it has. If it's listing the number of profiles, that equals the number of instances on the test, then you know that everybody was able to connect, everybody was able to exchange profiles. So yeah. Cool.
That's fantastic.
That's
And
me.
that's really good. And I just, for others, like, why did we bother with testground in the first place? This is awesome, but like, I think you know, why did we make this? No, it's a question to you.
You're asking
Yeah.
me. I thought you were
Yeah,
like
yeah, yeah.
rhetorically
I
saying
wanna
it so
hear
then
it.
you would answer.
I know I talk a lot, but hopefully you can take this one since you wrote all the code.
Okay, so we've had a lot of trouble in the past testing peer-to-peer network connections within our own testing environments. So not only is there a bunch that you have to set up and coordination that needs to happen outside of just the tests themselves, but they're decently finicky. And we wouldn't be able to test real live conditions. So like I was mentioning before about the networks being able to simulate latency and packet loss, we aren't able to, or the lift that it would take for us to test that in our own, or the normal Go testing setup is something that's beyond us to do effectively with the team that we have. And there's also, so getting to benefit from libp2p having to test their own stuff in this rigorous way, and so we're able to use technology that's already existing and getting made to leverage all this stuff. I think we'll probably want to end up spinning up something like this in our Circle CI testing checks. But yeah, keeping it separate from our normal, hey, go test environment, feels like it's the only sort of sane way to be doing this. Totally.
Yeah, and I mean, I think we've had a number of challenges designing peer-to-peer systems, right? Because it's a new thing. It's not well-charted territory. Like the Go language comes with an HTTP test package built into it, right? Like it's well understood how you. Well, it's not well. It's at least there are many good patterns that already exist for testing. But you and I, in working on this, we've designed algorithms in the past for coordinating sets of profiles. And as an example, the first versions, basically anytime it needed to appear, it asked anybody that was connected for a list of peers. And if you were to take that old version of our ID service and run that in this test grounds plan and turn the number of nodes up to 400, you would see how the whole network gets flooded with a lot of extraneous traffic just to coordinate peers, right? And so some basic concepts, and it becomes really hard to understand the repercussions of your code if you just look at unit tests, or if you just look at it hey, cool, a simple spin up 10 peers and connect them and then have that run every time with CI. And so
yeah, and that's a really good point. Right now, my focus in getting these test plans up and running, especially because it's all very new, is, hey, is this working? But the goal is to eventually be going, hey, when I make this change, how does it affect the network? And we would be able to see it and model it using
before we push it to production. Right?
Yeah, exactly.
I think that's the biggest challenge is without something like this, we have no recourse for knowing how something will skip, right? And we've run into this problem in the past. So that's really exciting. Thank you for that demo, Kasey. I know it's really technical, but very cool stuff. Yeah.
No problem. It's fun.
We'll add a link to the test ground project. It's query.io/test-plans. That's our clap from Dustin. But yeah, it's really exciting. For me, it's really valuable because it's the closest thing we have to something that will let us sleep at night. Right, for a long time, we really haven't known whether our peer-to-peer systems work the way that we want them to. And at least now we can sort of watch them a little bit and have a little bit better sense of peace with our peer-to-peer subsystems. Yeah, thank you so much. With that, I think that brings all the news that we had planned
Yeah, that's the end of the formal programming. I'll invite Caleb to chime in if he or she wants to, and let us know what interests you in query or not. Otherwise, we can just excuse us all, I suppose. But I just wanted to make sure that Caleb, it looks like you took the time to attend the call, so I just wanted to make sure we address any of your interests, problems, bugs, queries, anything that's on your mind. Just wanted you to know, here we are. And feel free to ask us whatever comes to your mind. Well, it sounds like you're trying to, I've got you really quiet. I can barely hear you. I can tell that you're trying.
Yeah, we know you're talking. We're just, it's inaudible, unfortunately.
Okay.
Actually, I'm not a data scientist or anything like that, but I'm a huge fan of the work. I'm now as a DevOps engineer, and I'm also most proficient with IPFS and this kind of stuff. And I'm just figuring out how can a humble software developer can help a platform that it's working on data sketch. So I'm trying to gather more people in this project because I think it's very cool. I'm always following guys in the everything you post, all the new stuff, and I barely know how to use Spark. But I think cool stuff would be if you are able to connect query to other platforms like NiFi and Apache Airflow. I don't know if this is in the roadmap. I saw Kafka in the issues, and I remember well. I like Pentaho. I like Airflow. Is it possible to use query with those kinds of platforms?
That is a wonderful question. Hopefully you can hear me okay. I just went to the Apache Airflow website and it seems to hurt my connection. I don't know if other people hear me. Anyways, and so we've been talking a bunch, and thank you for joining and thank you for listening in. As for getting other people involved, that's a great question. You should definitely chat in Discord about ways to get involved. And to answer your specific question, there's talk about Kafka. Kafka has come up from a number of places. I think that's the first sort of like big data oriented thing that we've been talking about. The first specific use case is using query as a sink for to read off the end of a Kafka message bus. I think Esmer's on the call and can correct my terminology, but that's some of the thinking, and so that is sort of some of the roadmap to work. It's definitely not, as you heard at the beginning of the call, we're really looking a lot at private data as something that is like kind of front and center for the next tranche of work from a technology perspective. We've had basically it's the private data folks showed up about a year before the Kafka folks. So, but that's not to say it's not prioritized. And this is where being an open source project is a really helpful thing in these cases, because if we want to see this happen, we can sketch out how we think that integration should look and feel. And then if others are willing to contribute it, then we will totally accept it and bring it into query. So yeah, to answer your question, I'm not sure how we'd integrate with Airflow right now. I know that, if you can distribute a CSV file, query can work with it, but that's not exactly, it's not always the easiest answer. I think it might be great if a query technician or engineer looked at Airflow as technology. If I understand correctly, Airflow is a scheduling tool, right? It's used for scheduling data ingest pipelines. Is that correct, Caleb?
It does a lot of stuff.
Thank you, Esmer.
Yeah,
do you want to explain it?
You're mostly on point. So right now, I'd say there is a hacky way with the new Python query library. That would be one way to hack into it. Other than that, I think we already started the discussion on one of the issues about providing connector API, and that was mainly geared towards Kafka API, as many of us so far mentioned it. But I think this is one more use case to just make sort of a bridge for many different connectors, and one of them being like specifically for Airflow. And I think generally there's a big use case for big data tools, or like at least large data tools, and this would kind of fit in.
Deep agree. We should get a channel going on Discord to talk about specifically integration with big data tools.
We also were talking about doing Apache Arrow integration a while ago, but not a lot of work has happened on that. It's still possible that it could happen down the road.
And I think Arrow is interesting in that it's sort of, Arrow is still sort of columnar in memory, single laptop. And so I think it's like basically the biggest data that you could fit on one machine would be the best way to describe Arrow.
That sounds close.
Yeah, I'm sure that the Arrow folks would be very irritated by that description, but it's close. Yeah, and so to that end, Caleb, these are great questions, and I'm going to take them and put them together and say the question about how do we get integration with big data tools and how do we get more people involved in contributing to query. Let's, as a team, sketch out what it would look like, sketch out the work involved to do integrations with specifically Kafka and Airflow, and if you could, Caleb could help us make sure that we're articulating use cases that you think are close to your heart, great. And if we can define those well enough as issues, they will be pull requests that we would totally accept into query. And some of this, to me, some of this actually feels like these are great chances to use query as a library, where we, as an example, like the Kafka side of things, we don't want to build Kafka connector code directly into the query core binary. What we probably want instead is, hey, you want query plus Kafka, so use this binary that imports all the query core code as a library and then exposes specific Kafka connector stuff, which is really nice because it'll be able to evolve independently from the core project itself. And will mean for less confusion when it comes to people trying to just work specifically Kafka and query. That will give them their own repository to land on. And so I'd love to sort of start sketching this work out, even though it's admittedly not sort of front and center for the query engineering team. I think this is a great chance for us to do a really good open source effort. And so, yeah, let's follow up in Discord and we'll get some GitHub issues going around this. That sound good?
Cool. I dropped a link to join our Discord, Caleb, in the chat. Otherwise, you can ping us on Twitter or however else you found us so we can make sure you get involved.
Great. That kind of covers it.
Yeah, and with that, I guess we'll wrap up and we'll see everybody on Friday for building query. Later, fam.
Thank you so much, everyone.
Bye-bye.
Bye.
See ya.